Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 437. In this episode, Scott talks with Michael Yarichuk about the document database RavenDB.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And we're talking with Michael Yarichuk from Hibernating Rhinos, the company that makes RavenDB, which is an open source document database. Thanks for chatting with me today.
Thank you, Scott. Glad to be on the show.
No, I'm thrilled to have you on. So you have been working with Oren on RavenDB for a year now?
About a year, more or less.
And this is an open source project, though, but you joined the company, is that right?
Yes. It's open source project, and Oren manages all the work like it's done in other open source projects. But he has a team. I'm not the only one on the team that works on RavenDB.
Mm-hmm. So yeah, RavenDB it's open source, and you can go up at GitHub and look at it. But then there's also commercial editions that you can use in a closed source environment, and it's really very nicely priced. It's not expensive, and people can use it in a subscription or in a closed source environment, and it's pretty clever way to balance open source and commercial. And it seems like a lot of the document databases are going in that direction.
Yeah, and I think that's the way to open source projects in general. Managing your business like in an open source way has much more advantages than disadvantages. So I am totally with Oren in this.
Yeah, and this RavenDB is getting used by a lot of really cool companies. I see that like MSNBC.com is using it, and it's getting people excited about NoSQL who maybe weren't NoSQL people. Maybe you can talk a little bit about that, the NoSQL movement, and what people who are more RDBMS, relational database people, why they should maybe switch sides.
Really, NoSQL movement. That's the anecdote of this. It started from a hashtag, really, the term NoSQL, and the reason the whole NoSQL thing started is simple: scalability. That was where big companies like Google and Amazon started to see that relational databases just don't fit the bill when it comes to performance-wise. They don't fit the bill.
So you're saying it started as a hashtag? Like someone was on Twitter just saying something, hashtag NoSQL?
No. The story goes that the first conference where some companies wanted to present what they have been working, they wanted to promote the conference, and I don't remember the name of that guy. He just thought about why don't make a hashtag to promote it in Twitter, and it was NoSQL. That's how it started.
It's so funny how movements like that, like these kind of hashtag movements start up, and then it's forgotten how where they came from. I didn't realize that's where NoSQL comes from. But it makes sense. It's one of those things where it gets into the mental consciousness, into the public consciousness.
It just took off. And the funny thing is, it's called a movement, but there is nothing no unifying traits that can define the specific database that is NoSQL. It's funny that the database which is NoSQL is defined, but what it's not. It's not a relational database.
But this is an interesting point. It is described, it's almost like I was going to say a vote of no confidence, but it's really just saying, relational databases aren't doing what we need them to do. So this is just, not that. I bet you if hashtags supported exclamation points, they might call it bang SQL instead of NoSQL. But you said scalability was the main priority. Are we saying relational databases can't scale?
Not exactly. You see, if you look on the history of relational databases, when relational theory was being written, the situation was different. It was designed to solve a different set of problems. Back then, storage was very, very costly. Hundred of megabytes could cost about $1 million in the 60s of storage. Programmers and IT people in general, their salaries comparatively to hardware prices was really small.
Mm-hmm.
And you needed to solve, in general, you needed to solve different set of problems. And NoSQL, as the way I see it, is just a reaction of our industry to how the situation has changed in terms of technology.
Well, that's interesting. I never thought about it in the context of space, that it was made at a time when disks worked a certain way, right? When disks were spinning metal, and it worked when memory was always, was at a
and the memory was much more expensive. There were much less users,
mm-hmm.
And in general, applications that stored information were designed to solve different type of problems, I would say.
Mm-hmm. So then, in this idea of different generations of databases, and that maybe there's some historical baggage with some of these SQL databases, when open source and document databases are moving forward, they have different kinds of storage techniques, right? There's key value storage, and there's document-oriented storage, there's graph databases, there's column-oriented, each one of them giving different kinds of scalability and performance.
Yes, but the thing is, and I sometimes like to refer that there is a very funny infographic that shows that describes those types of NoSQL databases as kind of evolution, and then document and graph databases being the top of the evolution chain. But the way I see it, it's compromises. What are you willing to sacrifice for performance and scalability? And I'm talking about, there are two types of scalability, horizontal and vertical scalability.
Mm-hmm.
And what I meant by scalability was that the idea that 5 cheap servers are much less expensive than one and very powerful one.
Okay. So it's rather than doing kind of like I know Stack Overflow, for example, their focus is on scale up. They use a SQL database, and they throw memory at it. And I think at last word it had 384 terabytes of memory, and basically holds the entire database in RAM.
Yes, and NoSQL databases. Here I think it's good time to mention what's called cap theorem.
Okay, what's that?
It's more or less describes how the databases can be compared. What I mean, the database types of relational and non-relational databases.
Mm-hmm.
It basically means that you have 3 things: availability, partition tolerance, and consistency. and you can only have only two of those.
Ah, okay. So you basically have these characteristics that you need, and you can pick not all of them. There is no perfect database. There's only the database that does what you need perfectly. And by the way, I misspoke. Of course, I said terabytes. I meant Stack Overflow SQL Server uses 384 gigabytes of RAM. So yeah, so you're saying that a database or a data structured storage really just needs to fit your needs, your specific characteristics of usage.
Yes, and basically. It's not absolute. So basically, all those types you mentioned, column databases, graph database, document databases, key value stores, without going to the specific features they provide, they essentially uphold to a certain extent two of those three ingredients, I would say, of database systems.
Mm-hmm. Amongst all of the different kinds of database systems that are out there that people know about, and one could argue that Redis is a kind of a database, Memcached is a kind of a database. It's a simple one; it's a key value cache, and Redis is more data structures focused. You've got these different kinds of things. Where in the pantheon of databases does RavenDB fit? Is it similar to Mongo and Couch? It's a document storage?
It's much more, it's a document storage database. It's most closest ones are indeed Couch and MongoDB. Mm-hmm. Certainly with respect to CAP theorem, they are both, if you do it as a chart, they are both more or less in the same area of, availability and partitioning.
Mm-hmm. That word you just said, did you say sharding?
That's part of it. Partitioning, it's how well your database scale, not upwards but sideways.
Okay.
Essentially, that's bit more involved than that, but essentially that's what it is.
That's interesting though, because I think that people who are listening are familiar with, basic databases, and they know that scaling SQL databases up is fairly straightforward. Throw memory and power and processor at the database. How do you scale a RavenDB database out?
Usually you add more machines, more nodes. There is sharding, it supports load balancing, and in my opinion, it's much easier to scale out than to scale upwards when you have the means, and it's the means in terms of features.
Mm-hmm. And I understand that Raven has this built in. It has replication and sharding support as features that are part of the product.
Yeah, that's integral part of the product, and that's one of design principles of RavenDB, that they just work. For example, if you want to with SQL, if you want to arrange replication to make it work, it will probably take how long, a week to or two.
Yeah, I've been there.
With RavenDB, I've done some demos. With RavenDB, setting up replication takes about 5 minutes. And
that's pretty amazing. The sharding support, of course, is done on the client side, right? It's a decision that's made on the client, while replication is done on the server, and those things can be, of course, used together. You don't have to pick one over the other.
Yes, and basically you have you can mix and match as needed. For example, you can set up sharded nodes that are replicate to each other and serve as kind of backup, and then you can make RavenDB to fail over to make a failover, and failover also a client side decision, and it's totally transparent, and it's done under the covers of the API of the client API.
Right. Okay. So then if I have my users, I can have one instance with A through M and another instance with N through Z, and that's sharded. And then I have a replicated instance.
For each of these shards, you can have replicated instance that will serve as backup.
And then it automatically can detect if a node is failing and then switch over and then figure out
without interruption, without need to without the need to manually do this either code-wise or operator-wise. The client side of RavenDB will handle the failover if it's set up to do so, of course.
And it has what's called, write assurance, right? It's making sure that this is really happening, and it is a transactional database. This is not fire and forget.
About that, RavenDB assures transactional consistency. Mm-hmm. It's both. It sounds a bit strange to say it both has eventual consistency and it has transactional consistency about promises. Mm-hmm. So eventual consistency, that's one of that's one of compromises I was talking about when I talked about CAP theorem, that if you need to have, in order to get performance, you need to sacrifice something. And
right.
that's one of the things that can be sacrificed, eventual consistency. So, RavenDB adopts eventual consistency with regards to indexes. So query, with regards to querying, RavenDB promises this query is accurate to a certain point of time. Mm-hmm. And the document store itself is transactional and acts accordingly. So the consistency is enforced in the document store, and the indexes of RavenDB what's they show its eventual consistency. Okay. So when you query RavenDB, the result will be accurate to a certain point of time.
Okay. So I want to take a brief moment because, we're getting into some interesting advanced stuff, but I want to catch up the listeners who may not be following everything that we're saying. So what you're saying is that this CAP theorem, which has been also known as Brewer's theorem after the gentleman that presented it, CAP is consistency, availability, and partition tolerance. So consistency, of course, is that every Raven node would see the data at the same time, and that everything would be consistent. And then availability would be that guarantee that you'll get a response in saying whether or not something was successful or not. And then partition tolerance, the P in CAP, would indicate that the system will still work even though there's a failure in part of the system. And the theory, the CAP theory, consistency, availability, and partition tolerance, is that it's impossible to do all three of those things at the same time. So that theory holds, right? It is not possible to do all of those. You get to pick two.
Yes, and RavenDB essentially it does kind of trick, because what I talked before, I thought now that maybe it wasn't clear enough. Mm-hmm. It has essentially it has two key value stores. One of them stores documents, mm-hmm. and it's guaranteed to be transactional, and the other one stores indexing information. Mm. And the indexing information is more volatile. It has eventual consistency because in order to gain more performance.
Ah, okay. So it's easy, it's fun to say, hey, you only get 2 of 3 of these things, but it's a misleading way of thinking about things because it's not an absolute. There's a continuum here that you work within. It's not a binary choice. You'll eventually get all 3 of those things. It just takes an amount of time.
And the amount of tricks you can make with the code, so to get better results.
Mm-hmm. And you guys, of course, believe that RavenDB is a great balance between getting you all of those things and getting you no locking and great scalability all at the same time.
Yes, and one of the things that allow technically, it's not true that there is absolutely no locking in RavenDB. RavenDB has minimum possible locking to still allow concurrency, mm-hmm. without the issues that follow if you don't do proper locking. But to do all those things, eventual consistency allows essentially to do querying without locking.
Right, exactly. So when you're querying something while writes are happening at the same time, what state are you going to get? The state of the data? If you've got like a shopping cart that's being written, many times a second, and then I do a query on that, what state am I going to get at that moment?
It's not. You're going to get a state. This indexing process is asynchronous to writes and reads.
Right.
And as you do writes and reads, indexing will pick up those changes eventually. That's what eventually consistency means.
Exactly.
And RavenDB has mechanisms in place that undercovers. They do batching and optimize how fast you will get and how up-to-date results you will get, depending on how the database itself queries is used. For example, tracking says how much queries per second, how much memory is available, how much the disk performance, stuff like this. RavenDB monitors all that and internally changes how things work to optimize as much as possible.
Mm-hmm. Are there different indexing strategies that I can ask it to say that I value one strategy over another, or is it just something that I don't worry about?
It's usually managed and being optimized in the background. You cannot influence which of the indexes get prioritized. It's get prioritized by which of the indexes needs the updates. I think it's a good place to mention the heavy lifting of indexing is done by Lucene.NET project.
Nice.
So you get also all sorts of goodies out of the box, like full text indexing, analyzers and stuff like that.
So you're using the Lucene, which is a very well thought of and very reliable project, which just, of course, makes your project more reliable as well.
It's very good and reliable project.
How many different things do you all rely on? You have quite an impressive. I mean, if you look at the GitHub, it's pretty amazing. You've got a very, very organized project, lots and lots of tests. You've got WinRT builds. You've got Mono for Android builds. How broad is this as far as how many different places can I use Raven, and what open source projects do you rely on to make that happen?
We rely on numerous open source libraries. First of all, what we rely on. Numerous open source libraries. I frankly don't remember most of them, but one of the more notable, for example, JSON.NET. It handles all the serialization. We use Web API with the third version, upcoming version. We use Web API. We use
I believe you guys use
managed ESINT.
And don't you use not Cecil, but rather N-Refactory?
N-Refactory, yes. That's one of them we use. There are some parts in code that
No, of course you can't.
Do not go too deep.
Yeah. But you've got clients basically everywhere. Is there? I mean, I can use this. I can talk to a RavenDB instance from a phone, from a Windows, from any Mono application, from WinRT, correct?
Yes. Also, we have a client. We have Java client side, native Java client side.
Java.
Yes.
Wow.
We have a team, offshore team that handles Java client.
Nice.
And also because RavenDB you can do anything with what you do with client API. You can do is RESTful. Basically, RavenDB, all client APIs, essentially REST operations. You can use RavenDB from any language that supports HTTP requests, basically.
Right. So if there wasn't a Python RavenDB client, I just talk straight HTTP and I could build one on top of that.
Yes, and for example, we have one client that built PHP client API for RavenDB.
Nice, that's cool. Now, I know that at its heart, it is RESTful, and the HTTP API is very focused on the cleanliness of REST, and it works just as you would expect. But I know that there's some other interesting optimizations that are there's a patching.
Yeah, there is one. I don't remember the name of it exactly. We allow to do scripted patches with JavaScript, so you can basically run kind of stored procedure. It can be thought about it as this to change your documents with JavaScript code.
So you can change just parts of them?
You can change part of them. That's not just it. There is patching API. Scripted patching API, you could do it with JavaScript, and you can do it with the strongly typed .NET API, C# API is basically, to add or edit parts of documents.
And it gives you a lot of granularity. I mean, this is an advanced topic, but it stood out to me as a very nice, clever way to, take a document that is perhaps a large document, and rather than retrieving it entirely from the server and then sending it all the way back, if I need to change just one aspect of it, I can. And I thought that was a nice optimization. And in .NET, it's a very clean API.
Yes, I totally think so. I think that there is really good job done on the API design to make it really intuitive. Before I joined Hibernating Rhinos, in my previous job, I evaluated the RavenDB for usage, and about 15 minutes I was able to write hello world program. In 20 minutes I had proof of concept up working.
Really? It's just that simple. Easy. So you download Raven and you basically run it at the command line, and it opens a port, and you bring in your client library and just start talking to it.
Yes, I was amazed how simple and intuitive it was to just start working with it. By the way, I just remembered you talked before about optimization of patching. Mm-hmm. With querying, you have server-side transformers, so you can make large document you can retrieve only things you need from large document.
So are you making a projection?
It's kind of server-side projection. For example, we had a client that complained that he had query times, response time of several seconds. And then I looked at his database, and he had documents. Think about JSON documents. There were several megabytes in size each one.
Oh wow! So hundreds of megabytes were coming across the wire. So it's not Raven.
So his example
network.
Query was 50 megabytes, and it's really, that was really hard. It took a long time to go that in the wire, and this kind of things can be amended by just using server-side transformer and fetch only the things you need from the server.
Mm-hmm. And that's how you worked through that problem?
That was basically suggestions to handle it.
Is there something that a document database is not useful for? What would I not want to do? What would be a bad, if I said, I'm going to pick RavenDB and I'm going to put this in it, what would be a misuse of a document database?
Reporting, for example. RavenDB is I can describe it as online transactional processing. That's what it's good for. Mm-hmm. And reporting for data aggregation and doing all sorts of things that data analysis guys do, OLAP, cubes, all this stuff. Mm-hmm. It can handle it, but if it was me, I would advise against it.
Mm-hmm. So this comes down to when you're sitting down and you're looking at a project, you really have to understand why you're looking at different databases and what characteristics that you need that database to have, because presumably when you're starting the project, that people will be mostly reading or mostly writing, or their behavior will be a certain way. a lot of people, I think, just pick a database and they throw it up there in one instance and then they poke at it, as opposed to really thinking about sharding ahead of time and how they believe users will behave and access that database ahead of time.
I think that's funny. I've been thinking about this same issue for some time now. I think many times it's just more than that. I think many times it's about cargo cult even. So someone comes to the company, they start and the company starts a new project and says, "Well, I work with Oracle and they have very good database and it always worked for me. Why wouldn't it work this time?" This kind of attitude, I think it's understandable because relational database dominated the market for at least 20 years without seriously considering what can be done better, because it just works. It works. Why replace something that works? When
and it works okay, right? It doesn't work.
You can make it work.
Exactly.
It will work. It will even at certain point of time return your investment sooner or later. But why not do better? And the way I think about it, I like to think about it. Sometimes people talk about polyglot programming, but what about polyglot databases? Single application can have multiple types of databases that are specifically optimized for certain kind of data. For example, one of the things we are working for next version of RavenDB is specialized storage for time series data.
Oh, wow. That's a good idea. That's a hard problem to solve.
Yeah, and one of the things we are working on, more or less it's finished, is new key value store. And with it, we've got, with it and with optimization we've got really amazing performance. I'm talking about order of millions of key value pairs per second. I don't remember the exact figures, but it gets to this kind of performance when you seriously optimize database for certain kind of data. And I believe that's the future of databases in general, that databases will get more and more specialized, because what I see is growing need in performance, more performance, because you get more and more users, more and more data. You need to analyze data faster and faster to stay in business.
Definitely. Well, folks can check out RavenDB at ravendb.net. And you can go up there, you can check out the downloads. They've got a really great series of videos explaining how to use it. There's classes, there's events probably nearby in your city. And of course, the code is all up on GitHub. Thanks so much for chatting with me today, Michael.
Thank you.
This has been another episode of Hansel Minutes, and we'll see you again next week.